Hello and welcome to Algebra 1 Lesson 48. In this video, we're going to learn about solving equations with rational expressions. So before we kind of jump in and start talking about solving an equation with rational expressions, I just want to refresh everybody's memory with something that we learned at the very beginning of Algebra 1. So I want you to recall that when we solve an equation with fractions, we can clear the fractions by multiplying both sides by the LCD. So as a quick example, let's say we saw something like 4/5 x plus 7/3 x, and this is equal to 94. Well, if I didn't want to work with the fractions, of course I could work with the fractions if I wanted to, but if I didn't want to work with them, I could multiply both sides of the equation by the LCD, and it would clear the fractions for me. So in this particular case, I have a denominator of 5 and a denominator of 3. Neither one of those is going to factor. So the LCD would be 5 times 3 or 15. So I would multiply this side of the equation by 15, and to make it legal, I would multiply this side of the equation by 15. Remember your multiplication property of equality. I can multiply both sides of the equation by the same non-zero value, and I'm not going to change the solution. So if I multiply 15 times 4/5, the 15 would cancel with the 5 and give me a 3. 3 times 4 is 12. So this would be 12x, and then let me erase this real quick. We would do that again over here. So plus the 15 would cancel with the 3 and give me a 5. 5 times 7 is 35, so it would be 35x. And this equals, we'd have 94 times 15, which would be 1,410. All right, so the first thing I notice now is that I don't have any fractions anymore. So now I just solve it as I normally would. 12x plus 35x would give me 47x, so this is 47x. This is equal to 1,410. Divide both sides of the equation by 47. And I will get that x is equal to 30. Now, on almost every occasion, I tell you to check the work to make sure it's accurate. I've already checked this. I know that 30 is the correct solution. But if you want to, you can pause the video and go ahead and check it. In the interest of time, I'm going to skip that for now and just going to kind of get to the main content of the video. All right, so now we want to talk about solving an equation with rational expressions. And the reason I gave you that example is because we're going to use a similar technique here. I want you to multiply each side of the equation by the LCD to clear the denominators, okay? So we're going to do that in this case just like we did in the previous example. The next thing you're going to do is you're going to solve the equation, and then we're going to check the solution by substitution, just like I always tell you to do. But here's the key thing. With a rational expression, when you have variables in your denominator, remember, we cannot divide by 0. So I have this statement here, we must reject any solution that results in a denominator of 0. Very, very important that you understand that, okay? If you want to look at the denominators before you kind of get going and say, hey, these are the restricted values, do that. That way, if you get that as an answer, you can just reject it immediately. Or if you want to go back and plug in, see what results in 0 after you've done the problem, that's fine too. All right, so let's take a look at the first example here. We have 1 over 3x, and this is equal to x minus 5 over 2x squared, and then minus 3x plus 3 over 2x squared. So the first thing I'm going to do is I'm going to figure out what the LCD is. Okay, what is my LCD? So in this particular case, I have a denominator that's 2x squared, and 3x. So if I break this down, I know this is 2 times x times x. I know this is 2 times x times x. And I know this is 3 times x. So again, we know how to get an LCD at this point. We've watched several videos where we've done this. And essentially, all I'm going to do is look for the largest number of repeats for any duplicate factor. Everything else just goes in. So for x, because it appears in everything, I just go with the highest exponent, which is x squared. Then for the number parts, I have a 2 here and a 2 here. It only occurs once in each, so that's going to go in there. And then I have a 3 here. Only occurs one time there, so I'm going to throw that in there. So I would have 3 times 2x squared, or what we'd say is 6x squared for my LCD. Okay, let me move this up here. So the next thing that I want to do, I want to multiply both sides of the equation by the LCD. So I'm going to have 1 over 3x. And I'm going to multiply this by 6x squared. And this is equal to, I'm going to put parentheses around this, x minus 5 over 2x squared minus 3x plus 3, again, over 2x squared, and I'm multiplying this guy by 6x squared. So let me scroll down and get a little room. We'll come back up to the original equation in a little while. So for this one over here, it's easy to see. I can cancel this 6 with this 3 and get a 2. I can cancel one factor of x up here with this x here. And so what I'm going to be left with is just a 2x right here. And this is going to be equal to, I'm going to use my distributive property here, 6x squared over 2x squared. The 6 would cancel with the 2 and give me a 3, and the x squareds would cancel. So essentially I would have 3 times this quantity x minus 5. So 3 times the quantity x minus 5. And then minus, I'm going to have 6x squared times this guy right here. Again, it's going to be the same thing. The x squareds are going to cancel, and 6 over 2 is 3. So I'm going to have 3 times the quantity, 3x plus 3. Okay, so moving on now, I just want to do some simplification. I have 2x is equal to, 3 times x is 3x. 3 times negative 5 is minus 15. Now I have a negative 3 here. Okay, so pay close attention. I'm going to distribute the negative and the 3 to everything. So negative 3 times 3x is negative 9x. Negative 3 times 3 is negative 9. So let's simplify now. I've got my 2x is equal to 3x minus 9x is negative 6x. Negative 15 minus 9 is going to give me negative 24. And now what I want to do is get all the x's on one side and the numbers on the other, right? Just like we've been doing since we started. So I'm going to add 6x to both sides of the equation. So I'm going to have 2x plus 6x, which is 8x. This is going to cancel, and this is equal to negative 24. We can then divide both sides of the equation by 8, and we're going to see that x is equal to negative 3. So let me erase everything, and I'm going to drag this answer back up to the top, and I'm going to check to see that this is a valid solution. Okay, so what I'm going to do is plug in a negative 3 for each x. And so I would have 1 over 3 times negative 3, which would be negative 9. We can go ahead and just do that. We'll put negative 1/9. This is equal to, plugging in a negative 3 here. So negative 3 minus 5 would be negative 8 over, plugging in a negative 3 there. Now it's going to be squared. I'm plugging it in for x. So negative 3, the negative and the 3 squared is 9. 9 times 2 is then 18. So I'm going to put 18 here. And then minus 3 times negative 3 is negative 9. Negative 9 plus 3 is negative 6. And then over, again, same thing here. If I take negative 3 and I square it, I get 9. Then 9 times 2 is 18. So I have minus a negative, that's plus a positive. So that's the only thing I want to do there. And so I want to just check this now. I see that plugging in a negative 3 did not give me a denominator of 0. So we're good to go there. Now we're just checking to see if the left and the right side are equal. So negative 8 plus 6 is going to give me negative 2. So this would be negative 2 over 18. So I get negative 1/9 is equal to negative 2 over 18. And this would be negative 1/9. If I simplify and divide numerator and denominator by 2, I would have negative 1 over 9 is equal to negative 1 over 9. So our solution here, which again was x equals negative 3, is correct. All right, for the next one, let's look at 2 over 5n plus 6 over n squared is equal to 2 over n squared. So what is the LCD here? What would that be? Well, we look at the fact that I only have a number of 5, no other number in any of the denominators. So that goes in there. And then each has an n. This one is n squared, and n. So we go with the highest exponent on the variable n, and that's a 2, right? So we just put n squared in there. So now that that's done, we want to multiply both sides of the equation by the LCD. So let me scooch this up, or actually I'm going to put it up here, make it nice and out of the way. And I would have 2 over 5n plus 6 over n squared. This is going to be multiplied by 5n squared. And then this is equal to 2 over n squared times 5n squared. Now, if you wanted to take the route of seeing what couldn't my variable be equal to before I start, I could do that. I could say, okay, well, I have an n here, an n squared, and an n squared. Obviously, n cannot be 0, right? It can be anything else other than 0. If I get a value of n of equals 0, I've got to reject that solution. But Just as valid, I could have not figured that out here, figured out the problem, and then came back up and plugged it in and say, okay, if I get an n net equals 0, then I've got to reject that solution. Okay, so let's go ahead and multiply. So use my distributive property, 5n squared times 2 over 5n. The 5s would cancel, and one factor of n here would cancel with this n, and essentially I'd have n times 2, which is just 2n. Then plus. Next I would do 5n squared times 6 over n squared, and the n squareds are going to cancel, and essentially I'm going to have 5 times 6, which is 30. Now over here I can just cancel this n squared with this n squared. 5 times 2 is 10, so this equals 10. And now we have a super simple equation to solve. I subtract 30 away from each side of the equation. I get 2n is equal to negative 20. So I divide both sides of the equation by 2, and I get that n is equal to negative 10. Okay, so that is not 0, so I know we don't have to reject the solution, but we still want to check it to make sure that we got the right answer. So important that we do that when we start out. Okay, so again, n is equal to negative 10. So I'm looking at 2 over 5 times negative 10. Just plug in a negative 10 for n. Plus 6 over, if I square negative 10, I get 100. And this equals 2 over, again, if I square negative 10, I get 100. So over here, if I multiply 5 times negative 10, I would have negative 50. Now, I need to get a common denominator going, so I'm going to do two things. I'm going to move this negative up into the numerator. Remember, that's perfectly legal. And then I'm going to multiply both numerator and denominator by 2. And so this is going to be negative 4 over 100. Negative 4 over 100. So negative 4 plus 6 is 2. So this side would be 2 over 100. And this side is 2 over 100. You could simplify each side to 1 over 50 if you wanted to. But you're just trying to see that the left and the right side are equal, which they are. So again, you can say that your solution here, n equals negative 10, is correct. All right, for the next one, I'm looking at 1 over v plus 6 minus 2 over v squared plus 3v minus 18. This is equal to 2 over v minus 3. All right, so this one's going to be a little bit more time consuming, but it's still not very hard overall. The LCD here is the first thing we want to find. So the LCD, what is that? Well, for this denominator, I have v plus 6. For this one, I have v minus 3. It's pretty straightforward. For this one, I need to factor it to see what's going on. Now, when you first start getting these problems, particularly in Algebra 1, you're going to be able to guess that one of these, at least, is going to be a factor of this. In this particular case, it's going to factor perfectly to give you those two. So give me two integers whose sum is 3 and whose product is negative 18. Well, of course, that's going to be positive 6 and negative 3. So you'd have v plus 6 and v minus 3. So your LCD is just that. It's v plus 6, which occurs here and here, and v minus 3, which occurs here and here. So once you have that, the v plus 6 times v minus 3, you want to multiply it by each side of the equation. Because of the length of my screen, I don't think I could possibly fit all of this in there. So without having to scroll back and forth, what I'm going to do, I'm just going to say that I'm going to be multiplying this by this side of the equation. So I'm going to multiply by this side, and I'm also going to multiply it by that side. But I'm just going to do the work down here and then just report the simplified result. So if I had v plus 6 times v minus 3, and I multiply this by 1 over v plus 6, obviously the v plus 6 would cancel here and here, and I'd just be left with v minus 3. So for the first one, let me kind of scroll down. I would have just a v minus 3. Okay, let me scroll back up now, and I'll just be going back and forth. So this was v minus 3 here. So now I'm going to multiply by this guy here. Now, the denominator here is exactly this. So we know that without even going through this, the denominator here is going to cancel with this right here. And I'm just going to be left with a minus 2, right? So if I was to write this over here, I would simply put minus 2 now. Then equals, I would be on this side now, and I would be multiplying this guy right here by 2 over v minus 3. So v minus 3 cancels with v minus 3, And I've got 2 times the quantity v plus 6. So 2 times the quantity v plus 6. Okay, so let's simplify each side and go ahead and solve. So negative 3 minus 2 is minus 5. So v minus 5 is equal to 2 times v is 2v. And then 2 times 6 is 12. If I subtract 2v away from each side of the equation and add 5 to both sides of the equation, what is that going to give me? This is going to cancel, and this is going to cancel. On the left side, I'm going to have negative v. On the right side, I'm going to have 17. So the opposite of v is 17. That means v is negative 17, right? I can show that by multiplying both sides by negative 1 or dividing both sides by negative 1, whatever you want to do. That gives me v is equal to negative 17. Okay, let's erase everything, and then we're going to go back and check. And I'm going to use the factored denominator to check. It's just going to be easier for me. So 1 over, you'd have negative 17 plus 6 minus 2 over, you have, again, v plus 6, so that's negative 17 plus 6, and that's multiplied by v minus 3, so negative 17 minus 3. These two quantities are multiplied together. This is multiplication. So make sure you don't just write it as one long string, because it's easy to just kind of substitute it in that way and not realize that it's multiplication and make a mistake. So it's this times this. Then this equals 2 over, you've got negative 17 minus 3. So let's crank this out real quick. Negative 17 plus 6 is negative 11. So I've got 1 over negative 11, or I can write negative 1 over 11. Does not matter. And then we're subtracting away. We have 2 over. Negative 17 plus 6 is negative 11. Negative 17 minus 3 is negative 20. So if I multiply these two together, I know I'm going to get a positive. So what is 2 times 11? Well, that's 22. Then just put your 0 at the end, the trailing 0. That gives you 220. Now this is going to be equal to 2 over negative 17 minus 3. So that's 2 over negative 20. Or again, I could write this as negative 2 over 20. Doesn't matter. So now what I want to do is just go through and simplify as much as I can. So I need to multiply this by 20 over 20 so I can have a common denominator. So 20 times negative 1 is negative 20. So I'd have negative 20 minus 2 over a common denominator of 220. So this would be negative 22 over 220. And what would that reduce to? Well, each is divisible by 22. 22 divided by 22 is 1. So this would be negative 1. And 220 divided by 22 is 10. So this is negative 1/10. So let me write that right there. This is equal to, if I divide this by 2, I get 1. If I divide this by 2, I get 10. So again, negative 1/10. And let me write it down here for the sake of completeness. We get negative 1/10 is equal to negative 1/10. So our solution, which we have down here, v equals negative 17, is correct. All right, for the next one, we're going to take a look at negative 2 over x plus 5 plus 3 over x minus 5. This is equal to 20 over x squared minus 25. So for the LCD, you can see here that x squared minus 25 is what? It's the difference of two squares. It's x plus 5 times x minus 5. And this matches what you have here and here. So the LCD is just this. The quantity x plus 5 times the quantity x minus 5. So if I multiplied, let me just write that the LCD is that. If I multiplied both sides of the equation by this, what would happen? Well, if I multiply this part right here by the LCD, the x plus 5 would cancel with the x plus 5 here, right? So what I'd have is a negative 2 times the quantity x minus 5, then plus. In this particular case, when I multiply this LCD by this, the x minus 5 is going to cancel, and it'll cancel here. So I'd have 3 times the quantity x plus 5. In this particular case, once I get past the equal sign over here, I have x plus 5 times x minus 5. So this is going to cancel completely with this, right? This denominator would just cancel itself out, and I'll simply just have 20. So now to solve this guy, negative 2 times x is negative 2x. Negative 2 times negative 5 is plus 10. 3 times x is plus 3x. 3 times 5 is 15. And this equals 20. Now, to simplify, negative 2x plus 3x is x. 10 plus 15 is 25. And this equals 20. Subtract 25 away from each side of the equation, and I get that x is equal to negative 5. So some of you will already see a problem, but let's go back up and substitute it in before we say anything. Let's go back up here. Let's erase. If x is equal to negative 5, what's going to happen here? When I plug a negative 5 in for x here and here, I'm going to have a problem, right? If I plug in a negative 5 for x there, I would have negative 5 plus 5. That equals 0. Division by 0 is not allowed. And if we get a result like that, we have to reject the solution. We reject x equals negative 5. It is not a valid solution. If I plugged it in here, negative 5, that quantity squared, would be 25. 25 minus 25 is 0. Can't have that. You could plug it in here. Negative 5 minus 5 is negative 10, but that doesn't matter. If it fails in one of the denominators, you have to reject it. You can never divide by 0. So that's what you're looking for here. You reject x equals negative 5. Let me just put a big, x through it and say it's not a solution. And so we don't have a solution here. We just say that there's no solution. There is no solution. All right, let's take a look at one more problem, and we're going to wrap this up. Again, very, very easy to do this. You just find the LCD, multiply both sides of your equation by the LCD, and then you just solve the equation like you normally would. The only thing is you can't have division by 0, so you've got to check that result so you don't get something like we did in the last problem. So to start this, 1 over 3v plus 15 minus 1 over v squared plus 5v is equal to 1/3. So again, I'm looking for the LCD. And for this guy, I've got to factor it. It can factor into 3 times the quantity v plus 5. For this guy, I can factor out a v, and I'd have v plus 5. And for this guy, I just have a 3. So it looks like I have a 3 here and here, so that goes in the LCD. I have a v, and then I have a v plus 5. So my LCD is 3v times the quantity v plus 5. Let's erase all this. I think I might be able to fit this on the screen, so let's try that. So I would have 3v times the quantity v plus 5 times 1 over 3v plus 15 minus 1 over v squared plus 5v, and then equals, and let me just scroll down and get a little room going. We have 1/3 there. So 1/3 times 3v times the quantity v plus 5. Okay, so we fit that on the screen. Now, what I'm going to do here is I'm going to be using my distributive property, and I'm going to distribute this to this. So if I have 3v plus 15, again, that's 3 times the quantity v plus 5. If I factor it, the v plus 5 would cancel with this, and the 3 would cancel with this. So essentially I have v times 1, which is just v. Now let me kind of erase what I canceled there and do this again. We're going to use our distributive property over here. Now in factored form, this is v times the quantity v plus 5. So in this particular case, the v is going to cancel, and the v plus 5 is going to cancel. So that's gone, and what I'm left with is 3 times 1, or just minus 3. So then minus 3. And then over here, if I look, only a 3 is going to cancel, so I'm left with equals v times the quantity v plus 5. Okay, so we've got it in kind of a simple form. It won't take us very long to solve this now. We have v minus 3 is equal to v times v is v squared plus v times 5 is 5v. Okay, so now what I want to do, I want to subtract v away from each side of the equation, and I want to add 3 to both sides of the equation. So that's going to cancel itself out. So I'm going to have 0 is equal to v squared plus 4v plus 3. Now, we have this set up as a quadratic equation. We cannot solve quadratic equations that we can't factor because I haven't taught you how to do it yet unless you know how to do it from outside of my course. There is something called the quadratic formula and completing the square that we're going to get to at the very end of Algebra 1. So until we get to that point, unless we can factor this, we cannot solve it. But fortunately, I gave you a problem that you could do. So this is going to factor into what? 2 integers whose sum is 4 and whose product is 3. That's 3 and 1. So I would get that v plus 3 is equal to 0, or v plus 1 is equal to 0. So solving that, I just subtract 3 away from each side here. I get v is equal to negative 3. And then over here, I subtract 1 away. I get v is equal to negative 1. So here are my two proposed solutions. Let's go back up and check them. Okay, so let's check each one separately. And so I'm going to do 1 over, let's start with negative 3. So 3 times negative 3 is negative 9. And negative 9 plus 15 is 6. Then minus. I've got 1 over v squared, negative 3 squared would be 9. And then 5v, 5 times negative 3 is negative 15. So 9 minus 15 would be negative 6. So this would be minus a negative 1/6. So this is plus positive 1/6. So essentially we could write this as what? 2 over 6, which is 1/3. So this is 1/3. And this says 1/3 over here. So this one checks itself out. This is good to go. So now let's try negative 1. So 3 times negative 1 is negative 3. Negative 3 plus 15 is 12. So this is 1 over 12. And then minus, I'm going to have 1 over v squared. Negative 1 squared is 1. So this would be 1. 5 times negative 1 is negative 5. So 1 minus 5 is negative 4. So I'd have minus a negative 1/4. Now, this is plus a positive, and I could change this into multiplying by 3 over 3. So this is going to be 3/12. So 3/12. Now, if I add 1 and 3, I get 4. So this is 4/12. And what does 4/12 reduce to? It reduces to 1/3, right? 4 divided by 4 is 1. 12 divided by 4 is 3. So I get 1/3 equals 1/3 from over there. So again, we found the big winner. So v can equal negative 3, or v can equal negative 1.